Hello everyone, in this video I'll be explaining the problem ones and zeros 1. So it was asked in Codechef contest status 219. So let's read out the problem. Given a binary string, so fs is defined as follows. A prefix s from 1 to I is called good if it contains at least as many ones as zeros. Okay, so fs is the number of good prefixes of the string. Got it. So you are given a binary string s of length, find fs. Input we have integer test case, then for every test case we have n as the length of the binary string, and then in the next line we have binary string. So we have a lot of test cases. For let's try to understand. So in the first one we have 0 0 0 0 0. So let's go to the board and let's see how to solve this. So yeah, we have first test case wherein your string is 0 0 0 and n is equal to 3 because it's a 3-line string. So in the problem, question what they've said is we need to find fs. S is basically binary string. Binary string means it contains only zeros ones. Okay, so what fs is defined? Fs is defined as number of good prefixes. Okay, prefixes, or you can say number of prefix subarrays also you can say. Sub strings. So we need to find this. Now how good prefix is defined? So it is defined as from 1 to I, it is 1 based indexing. Okay, so from 1 to I, the count of zeros, okay, if you take j is running from 1 to less than equals to I, the count of 1 has to be greater than or equals to count of 0. Okay, so this is the thing. If you find it, it's like a good prefix, or it's not. So let's try to find the substrings from 1. Okay, we can find a lot of substrings. This is also a substring, but it is not starting from 1. It's a 1 based indexing, so you should start from 1. So s of 1 to 1 is 0, s of 1 to 2 is 0 0, s of 1 to 3 is 0 0 0. The count of 0 is count of 0, okay, let me call z, is 1, and count of 1 is 0. We don't have any 1 here also. So it's not a good prefix. Here count of 0 is 2, count of 1 is 0. It's also not good. Here if you see count of 0 is 3 and count of 1 is 0. It's also not a good. Okay, so we don't have any good prefixes or substrings. So here fs is going to be 0. So we need to print 0. Now let's try to take the second case. In the second case we have 0 0 1. Okay, again same thing from 1 to 1, 1 to 2, 1 to 3. So 1 to 1 we have 0. So count of 0 is 1 and count of 1 is we don't have. So it's a not good prefix. Okay, and this also same thing, not good prefix. And here if you see count of 0 is 2, but count of 1 is 1. Still count of 1 is not greater than or equals to, right? So it is also not good prefix. Okay. Now let's take the third one wherein we have So we have n is 5, string as 0 1 1 1 0. Okay, now let's take prefix from 1 to 1, prefix from 1 to 2, prefix from 1 to 3. It's a 5 index, 1 2 3 4 5. Okay, so 1 to 1 is 0, so count of 0 is 0, 1, and count of 1 is 0, so it's a not a good prefix. Okay, now here it is 0 and 1. Okay, count of 0 is 1, count of 1 is also 1, so this condition is following now. Count of 1 is greater than equals to count of 0, so it's a good prefix. Okay, and 1 2 3, if you see 0 1 1, so here count of 0 is 1, count of 1 is 2, so it's also a good prefix. Okay, because count of 0 count of 1 is greater than equals to count of 0. 1 to 4, if you see, it is 0 1 1 1, so your count of 0 is 0, count of 1 is 3. Again, sorry, it's not 0, it is 1, we have 1, so it's a good prefix. If you see the last one, so we have 0 1 1 1 0, here count of 0 is 2, count of 1 is 3, still here it's greater, right? Count of 1 is greater than count of 0, so it's a good prefix. So how many good prefix we have found? 1 2 3 4, so here fs is 4. So as you can see here, fs is 4. So how do we solve this? As you can see, we need to make sure we create prefixes. So optimally what I'll try to do is, I will try to take two variables. We can do with one variable also, but let me make sure the code is more readable and you understand. So I'll take two variables, so one which is 0 initially, and then I'll take 0 which is 0 initially. 1 is basically it keeps count of how many ones we've occurred, it keeps count of how many ones we've occurred. So I'll run a loop from 0 to n minus 1, and I'll check accordingly if s of I is 1, then 1 is going to increase, else 0 is going to increase. Okay, so when I move to first one, so we have 0, so here 0 is going to be 1. Okay, now you need to check the count. It's like index from 1 to 1. Okay, now you need to count which is 1 is greater than equals to 0. No, so let's give an answer which is 0 initially, so it is 0 only, and when you're moving forward, so it's 1, so your 1 is going to increase. Okay, now count of 1, it's like a substring from 1 to 2, right? So here your answer is going to be 1. Next you move forward, so it is going to be 2. Again here 1 is greater than 0, so you have, when you move forward, so count is 3, 3 is greater than 1, so you have one more good prefix. Then you move forward, it is 2, again 3 is greater than 2, so you'll have to increase answer by 1. Okay, so here one condition will be, if 1 is greater than equals to 0, your answer is going to be increased by 1. When you come out of the for loop, you'll have to print answer. So that's it. It's like a one pointer approach, basically scanning the string. So let's try to code it up. So in the input what we have is test cases, and then n is the size of the string. Then we have string. Okay, now we'll take one variable 1 and 0, both has frequency 0 initially. Now we'll check if s of I is 0, so 0 plus plus or else 1 plus plus. Now here we'll have to check if 1 is greater than equals to 0, so your answer is going to be increased by 1, and we need to take one answer variable initialize to 0, and then we'll have to display answer. Here it is, sample test getting passed. Let's try to submit in the online editor. Yeah, it got accepted and beats, passes all the test cases. So yeah, thank you guys for watching the video.